Hi, I just wanted to show you one thing that I think I forgot to talk about last time. When I first started talking about hypothesis testing, I was saying that larger t-scores, I mean, um, larger test statistics give you more evidence that the null hypothesis is false. And in a t-test, the test statistic is the t-score, which would mean that larger t-scores would be giving you more evidence that the null hypothesis is wrong. But um, what does a larger t-score really mean? You can have positive and negative t-scores. In the case of a t-test, a t-score that's further away from zero is actually giving you more evidence that the null hypothesis is wrong. A t-score close to zero, a t-score that's closer to zero gives you less evidence that the null is wrong, and a t-score further away from zero at either end gives you more evidence that the null is wrong. And so as you move away from zero in this direction, larger t-scores give you more evidence. So we're starting to move across the data sets that are showing more evidence that the null is wrong. And at a certain point, we reach the critical value where this is considered enough evidence that the null is wrong to reject the null hypothesis. As you move away from zero in the negative direction, you're also starting to move across values of t that show more evidence that the null is wrong. And at a certain point, you reach the negative critical value, which is also the point where you have a t-score that shows enough evidence that the null is wrong to reject the null hypothesis. That's why you have critical values at both ends, because the areas, the data sets or the samples out here at this end show strong evidence that the null is wrong, and that the data sets or the samples way out here at the left end also show strong evidence that the null is wrong, because both are far away from zero. So basically, if you end up collecting a sample that gives you a t-score in the rejection region down here, or if you get a data set with a t-score up here above the positive critical value, both of those data sets would be considered to be showing strong evidence that the null is wrong, because both of them are far away from zero. And a data set that gives you a t-score of 0 is actually a data set that shows no evidence that the null is wrong. If your t-score ends up coming out to 0, you've shown no evidence that the null hypothesis is wrong. I just wanted to clear that up because I talked about how a larger test statistic means more evidence against the null hypothesis, but in this case, further away from 0 in either direction means more evidence that the null is wrong.